Hi students, this is a lecture number 2 in chapter trigonometric in the 10th class. We are going to solve an example problem here. That is, they have given a right angle triangle with this hypotenuse, and this is A, B, C. Here we have the angle C, and we have the right angle triangle is B, 90 degrees. And here we can find the ratios related to angle A are ratios related to angle C. Both are different. Okay, for example, if they ask to find sine C, then the opposite side, as we have seen in the previous lecture, opposite side to the angle C is AB, and the same way if you see the opposite side to angle A, that is BC. Okay, so you should be careful which angle they are asking. For example, if they ask sine C, that is length of the opposite side to angle C is nothing but AB and divided by our hypotenuse AC. Suppose in the example problem they mention the lengths in centimeters, that is length of BC is 5 centimeters, length of AC is 13 centimeters. Then if they ask find sine C, it is going to be, and suppose this they have given 7 centimeters, AB also given, AC is also given, BC lengths all are given, and they ask sine C, so opposite side, length of the opposite side, it is 7 centimeters divided by AC is nothing but 13 centimeters, length of AC. And since it's a ratio, centimeters will get cancelled, and we get the sine C is going to be 7 by 13. Okay, suppose if they ask to find what is sine A, so now when we watch from angle A, the opposite side to angle A is nothing but BC. So the length of BC divided by hypotenuse. Hypotenuse is going to be same in angle C case or angle A, that is going to be AC. So the length of BC it is 5 centimeters and divided by the length of AC it is going to be 13 centimeters. Centimeters, numerator and denominator will get cancelled, and we get it as 5 by 13. That is going to be sine A. Similarly, if they ask what is cos C, here whenever we want to find the cos of an angle, we have to find the length of the adjacent side. Adjacent to angle C, it is nothing BC. Length of the adjacent side, it is BC, divided by the hypotenuse, that is AC. So length of BC is nothing but 5 centimeters, and length of the hypotenuse it is going to be 13 centimeters. Again centimeters will get cancelled, since it's a ratio, it is going to be constant. 5 by 13 is going to be cos C. Suppose we want to find what is cos A. Cos A we want to find, adjacent to angle A is nothing but AB. This is the adjacent side to angle A. So length of AB is going to be 7 centimeters and the length of the hypotenuse is going to be 13 centimeters. So we get it as cos A is going to be, we have AB 7 centimeters divided by 13 centimeters, we get it as 7 by 13. This is going to be cos A. Okay, so like this we can find the ratios related to cos A, cos C, or sin A, sin C. And another important relation here we get with respect to the ratios is, we have seen already that, again I am just briefing here, we know that sin A is 1 by cosecant A, and cos, we have cos A is nothing but 1 by secant A, vice versa we can write. And another we have tan A is going to be 1 by cot A. Remember these ratios. And tan A is nothing but we have length of opposite side to the angle for which we want to find the tangent divided by length of adjacent side for which we want to find the tan of the angle. So we know, we have seen already that sine A is nothing but length of opposite side and divided by hypotenuse, length of hypotenuse, HYP we can hypotenuse, whereas cos A is length of adjacent side to the angle A divided by length of hypotenuse. Okay, suppose if you take the ratio of this sin A by cos A, the length of hypotenuse will get cancelled and we get it is nothing but sin A divided by cos A if you take. So lengths of hypotenuse would get cancelled and we get length of opposite side divided by length of adjacent side. So which is nothing but basically the ratio we have is tan A. So finally what we can write here is, you have to remember this, tan A is going to be sin A divided by cos A. And we know that tan A is opposite of cot A, the reciprocal of cot A. So cot A we can write it as cos A by sin A. These ratios are very useful. Tan A is sin A by cos A and cot A is nothing but cos A by sin A. We'll see one example problem here to understand the ratio of tan A. So example number 2 for this class we have. So we take the right angle triangle like this and we have angle A here and this is B we take and this is C, and the length of opposite side to angle A is BC and the length of adjacent side to angle A, that is AB, is 4K. This is given. And now above we have seen tan A is the ratio of opposite side to the angle A, that is 3K, divided by adjacent side to angle A, that is 4K. And here we can cancel the constant K from numerator and denominator and we get it as 3 by 4. So this is going to be tan A is 3 by 4. Suppose if we find the values of sin A and cos A and take the ratio, we are going to get the same answer here. Now to find the values of sin A cos A ratios, we need to have the length of AC. Okay, to find the length of AC, we are going to use a formula or a theorem here which is called as Pythagoras theorem. Okay, we are going to use a Pythagoras theorem here. Pythagoras theorem, which is used to find the length of the hypotenuse. What this Pythagoras theorem states, the square of the hypotenuse is equal to sum of the squares of opposite side and adjacent side. Sum of the squares of opposite side and adjacent side, that is AC is the hypotenuse, so AC square is equal to BC square plus AB square. BC square plus AB square. This is what the Pythagoras theorem states. Now we know what is AB, that is 4K, and we know what is BC, that is 3K. So we have here 4K whole square and 3K whole square. So we know that 4 square is 16, K square, 3 square is 9, K square. So 16 plus 9 we have 25 K square. So this is nothing but AC square. So if you take the square root on both sides. Square root on both sides. So we get AC square root of AC square 25k square square root. The square and the square root are going to get cancelled from LHS in both sides. And here what we have written 25, that we can write it as 5 square. So this square and the square root will get cancelled. Or another step we want, you can write like this, 5k whole square. Now this square and square root will get cancelled. What we get is 5k. So hypotenuse AC is going to be 5k. This is the length of the hypotenuse, which we have written HYP. The spelling we can have HYPOTENUSE, hypotenuse. That is length of the hypotenuse. AC we got using the Pythagoras theorem, that is going to be 5k. Now we can take the ratio of opposite by hypotenuse. So what we get, I give some 2 seconds, you can just, what we get, I will just write the right hand side, where I am writing opposite side, length of opposite side to angle A divided by length of hypotenuse. So what it gives, the ratio what I have to write on the left hand side, I think you guessed already, it is going to be sin A. Okay, so length of the opposite side here we have seen already, that is BC, and hypotenuse, that is BC equal to 3k, and AC is going to be 5k. Okay, so here we got 3k divided by 5k. So both the k will get cancelled and we get 3 by 5 here. So this is going to be sin A. Now similarly we can find cos A, cosine A. I'll give 1 or 2 seconds, you can tell what is RHS. In the denominator it is going to be length of hypotenuse. What it is in the numerator, can anybody tell? It is length of adjacent side, length of adjacent side to angle A. So to angle A, adjacent side is nothing but we have 4k. To angle A, adjacent side is 4k, and divided by length of the hypotenuse, that is 5k. So this we got it as 4 by 5. K will get cancelled. Now if you take the ratio of sin A by cos A, we take the ratio of sin A by cos A, what we get here, sin A is 3 by 5, cos A is 4 by 5. We know that 3 by 5, 5 comes in the denominator. In the denominator 4 by 5, we can reciprocal when it goes into numerator, we get 5 by 4. So this 5 numerator, denominator 5 will get cancelled, we get it as 3 by 4, which is nothing but we already done it as tan A. So we can finally write it as, already we have written that sin A by cos A is nothing but tan A. Okay, so once we know what is sin A, we can easily calculate what is cosecant A. Okay, I am writing here with the red color. Cosecant A is nothing but reciprocal of sin A. If you take the constant here, that is 3 by 5 we got for sin A. Cosecant A, it is going to be 5 by 3. That is length of hypotenuse divided by length of opposite side. 5 by 3 is going to be cosecant. Now similarly cos A we have, if you want to have secant A, that is reciprocal of cos, we get it as 5 by 4. Length of hypotenuse divided by which side length? For secant A, it is length of the adjacent side. Okay, this is for today's class. Okay, please subscribe and share this video. Thank you very much.